Question 2. The function f is defined by f of s equals 1.43 to the x plus 0.57, and the function g is defined by g of s equals 14x plus 12 over x plus 12. The graphs of the function f and g intersect at the point 1, 2, and a, b. So this is point 1, 2, and a, b right here. For s greater than or equal to 0, the equation y equals g of s right here can be written as s equals h of y equals 12y minus 12 over 14 minus y, where h is a function of y. The graph of x equals h of y and the horizontal line y equals 3.5 are shown in the figure number 2 right here. This is 3.5, right? Question A. Let R be the region bounded by the graph of G, the x-axis, the y-axis, and the vertical line x equals 1, as shown in the figure 1. Find the area of the region R. So, the region R is right here. And you know that the area bounded by the region R and the x-axis is going to be in row form 0 to 1, right? 0 to 1 right here. G of s subtract the x-axis, which is y equals 0, right? So top subtract bottom ds, right? So we're going to copy this one over here, and it's going to be actually in row from 0 to 1, g of s ds, right? So we're going to print up the calculator. G of s is right here, right? So we're going to hit add calculator, hit the button right here, input the interval from 0 to 1, right? And g of s is this guy. We just input this expression, right? Then you're gonna hit Control Enter. It's gonna be 1.513. Now question B. The region R described in part A is the base of a solid. For this solid, its cross section perpendicular to the x-axis is a rectangle whose height is 1 over 3 times the length of its base in the region R. Write but do not evaluate an integral expression that gives the volume of the solid. Alright, so basically we need to calculate the volume of the solid using the cross section, right? So the region R is right here. Then the cross section is the rectangle, right? So it's going to be something like this. The base is the difference between g of s and the x-axis, which is y equals 0, right? And the height is 1 over 3 times the length right here, g of s, right? So the error is the integral from 0 to 1, length times height, right? So it could be g of s minus 0, it could be g of s times this guy right here, 1 over 3 times g of s ds, right? I copy this one down over here. Now question C. The shaded regions in figure 1 is bounded by the graphs of f and g on the interval from s equals 0 to s equals a. Find the area of the shaded regions. Alright, so s equals 0 is right here and s equals a is right here. Right? Now, from 0 to 1, we know that the function g of s right here is below the function f of s, right? So we have the error is the interval from 0 to 1, we have f of s subtract g of s, right? ds. Now from 1 to a, the function g of s is above f of s, right? So we're going to add the interval from 1 to a, g of s subtract f of s ds, right? Now we need to find the intersection right here. So we have the function f of x right here, and the function g of x is right here, right? So we're going to use the calculator to find the intersection, right? Home screen, go to graph. Alright, so I'm going to input the first function. It could be 1.43 raised to the x plus 0.57, right? And then press enter. It's going to be right here. Now hit tab, input the second function, and then press enter. It's going to be right here. Alright. Now we need to find intersection. We know that the intersection right here is 1, right? So we don't need to find this one. Now we need to find this guy right here. So press menu, analyze graph, number 4. Go to the left, go to the right of intersection. It could be 3.26, right? So A right here equals 3.26, right? So I'm going to copy this one over here. So I need to store the function. So I'm going to press home screen, go to calculate. Now I'm going to input f of x and press control the button right here. Alright, f of x equals and press enter. Alright, now I'm going to store the second function g of x. I do exactly the same thing, right? Alright, now you're going to press the button right here, input the interval right here from 0 to 1. Of f of x minus g of x. I'm going to copy this one over here. Interval from 1 to 3.26. G of x subtract f of x. Press Control Enter. It's going to be 0.632, right? Question D. Let T be the region bounded by the graph of x equals 2y, the y-axis and the horizontal line y equals 3.5, as shown in the figure number 2. Write but do not evaluate an integral expression that gives the volume of the solid generated when region T is revolved about the y-axis. Alright. So region T is right here. If this guy revolves about the y-axis, it could be something like this. Alright, now we're going to use the disk method, right? And the radius is right here. One, 2, 3.5 of x right subtract x left, right? All together square dy, right? So it could be integral from 1 to 3.5. X right is the function h of y right here, right? So we have 12y minus 12 over 14 minus y, right? Subtract x left, which is 0, right? And all together square dy. Don't forget to multiply by pi, right? So I'm going to copy this one over here. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.